So welcome back, physicists and earth space scientists, to the Level 1 NCEA standard, looking at the Earth, Moon and Sun system. Today we're looking at the tides and the moon, especially in the context of New Zealand and the Pacific region. So in terms of understanding tides, we need to have a definition of a tide. So essentially a tide is the regular rise and fall of the ocean caused by the gravitational pull of the moon primarily, and also in some cases the sun. And the focus of this lesson will be how the moon's gravitational force affects the tides and creates those tides. So high and low tides. So high tides occur when the moon is directly overhead or on the opposite side of the earth and is caused by the gravitational pull of the moon on the water. So in coastal areas, you're going to experience that rise in sea level. In terms of low tides, these occur between high tides, and this time the coastal regions experience a drop in sea level. But that's not quite the whole story, because you'll see that they form on both sides of the earth. So why is this? Well, tides form on both sides of the earth due to the interplay between gravity and something we learned in the mechanics, external inertia. So just breaking that down to you, so gravity, the gravitational attraction between the Earth and the Moon is strongest obviously on the side of the Earth that happens to be facing the Moon, and the gravitational force pulls the water on the near side of the Earth towards the Moon. However, on the opposite side, inertia, which is the tendency of an object to keep moving in a straight line unless acted on by an external force, on the far side, then the gravitational attraction is weaker because it's further away, so inertia dominates, and the water tries to keep moving away from the Earth, therefore forming that second bulge. Okay, so essentially what happens is that gravity and inertia act in opposition on the Earth's ocean, creating these two tidal bulges on opposite sides of the planet. So on the near side, you've got the gravitational force of the moon pulling the ocean's waters towards it, and on the far side of the Earth, the inertia dominates, creating that second bulge. Okay. So in terms of different types of tides, there's three major ones we look at. So the first one is spring tides. Okay, so spring tides occur during the new moon and full moon phases, which we'll explore in a later lesson. And that happens when the gravitational force of the moon and the sun align, as you can see from the image there, causing these stronger gravitational forces and therefore stronger tides. So the effect of that is higher high tides, exceptionally high water levels compared to normal high tides, and lower low tides because of that as well. So exceptionally lower water levels in the oceans or in coastal areas due to this doubling up of the gravitational effects of the sun and the moon. We also have neap tides, and a neap tide occurs during the first quarter and the third quarter moon phases. And in this example, the gravitational forces of the moon and the sun partially cancel each other out because they're at 90 degrees or right angles to each other, as you can see in the diagram. And the effect of that is you get slightly lower high tides and slightly higher low tides. And so you get that less extreme variation between the high and low tides during that period because there's less gravitational pull overall due to that cancelling out effect. And then we have perigean spring tides or king tides, the last example, and that's a rare occurrence when the moon is closest to the Earth, known of course from our last lesson as the perigee, and also has to happen during a spring tide, so when the Earth, Moon and Sun are all aligned together. And you get amplified tidal effects, so extremely high tides now and extremely low tides, and because of that, you sometimes get coastal flooding in some coastal areas when these events occur.